So this is, I think, the fifth example video for conservation of momentum and some conservation of energy and the idea of collisions. So we worked this problem in the last video. If you have not watched that video, you should stop this one and go back and look at that one. But we solved the previous example for if we knew the angles and didn't know V1 final and V2 final. What happens if we know V1 final and V2 final, but we don't know the angles? I found that leads to a little bit of consternation, because it's easy to eliminate a variable like V1 final. We just solve one expression for it, substitute it back into the other one, or any method you choose. But that doesn't really work for solving for angles, because I can solve this for cosine theta and solve this for sine theta, but I can't just eliminate that. Of course, I can divide them and get a tangent or cotangent theta, or phi theta, whatever. But that doesn't really help necessarily. So let me kind of show you how to handle that, or at least to get you started. So we're going to assume we're going to start here. We're going to assume that we don't know these angles. And how do I eliminate an unknown angle from my expression if it's buried inside a trigonometric function? So let me solve this expression for sine phi. I'm going to move this term over and divide out by m1 v1 final. Again, stop the video and take the steps. Will be very useful for you to do that. So let's say that sine phi is going to be equal to, what I'm going to get here, m2 v2 final from here, divided by m1 v1 final from here. And then I've got a sine of theta here. All right, fair enough. This is sine of phi. Now let me solve this one for cosine of phi. I'm going to, same procedure, move this over and divide by m1 v1 final. I have another term, so it's a little bit more complicated. But what I'm going to get there is this m v initial minus m2 v2 final cosine theta divided by m1 v1 final. And I forgot to solve, put over here what I'm solving for. This is solving for the cosine of phi. Now again, if I were doing a v1 final, a v2 final, some other variable, I would have solved this expression for one of them and this expression for another one, and set them equal or back substituted, form a matrix, however you want to do it. See the previous video for that. But if you need the angles, I found that oftentimes we get stuck here. What I would like to remind you of is the fundamental trigonometric identity. Sine squared phi plus cosine squared phi is equal to 1. This enables you to eliminate angular variables that are buried inside trigonometric functions like this. You square this and you square this. This is, after all, sine of phi. This is, after all, cosine of phi. So you square this, you add them together, and that summation has to equal 1. And in that expression, all that appears is a sine phi and a cosine, a sine theta and a cosine of theta. They're going to be squared. And there's quite a bit of algebra in front of you, but just to remind you of how that works, I found that lots of my students forget that this is a thing when they get here. So again, there's a little bit of algebra in the future. You should go through the steps to make sure you can do it and make sure you understand how it works. But this is the procedure you would follow when wanting to eliminate angular variables buried inside trigonometric functions.